Okay students, in this video I am going to present introduction part to functions part 3. So in the first part I told about the definition of the function and what are the conditions for a relation to make it as a function. Second one I discussed more about one-to-one function and onto function. Okay, now I am going to teach the ways of representing the function. Suppose a function is given, then what are the ways used to represent that particular function? Okay, here some of the ways you already studied in 10th standard, but here you are going to study one new way of representing the function known as the analytical representation of function. Okay, now ways of representing function. A tabular representation of a function. Students, you already studied this in 10th standard. Tabular way means what? X values you will take 1, 2, 3, 4, y values, f of x, for example x square plus 2, simply have to substitute 1, 2, 3, 4, something like that. So this is very easy tabular form. I am not explaining deeply because you already know that form. Next, graphical representation of a function. This also you know in 10th standard. Graphs and all you draw. Okay, by taking x values, you can write y values. Then you will get something like parabola shape. Okay, so first two methods you already know, that's why I am not discussing much about that. Third method is very important method. This is a new method known as the analytical representation of a function. Suppose if any function f of x is there, if you write y is equal to f of x, that representation is known as the analytical representation of a function. That means f of x is a function of x. Okay, so y is equal to f of x means, for example, if I take y is equal to x minus 1 by x plus 1. So it is like y is equal to f of x. Okay, y value depends on x. Okay, so y is a dependent variable, x is the independent variable. I already told you. Similarly, y is equal to square root of 9 minus x square. This is another example. So y is equal to f of x. F of x is square root of 9 minus x square. So y is equal to sin x plus cos x. So same, y is equal to f of x. For example, area is equal to pi r square. So this is also a function of radius r. And some more examples. Y is equal to x cube plus 3. Y is equal to x power 4 minus 2. Y is equal to x minus 1 by x plus 1. Y is equal to square root of 4 minus x square. These are all analytical ways of representing the function. Students, we are going to deal more about the analytical ways in problems also. Okay. So what is the use of representing functions analytically means you can find their domains and range very easily. Okay. For example, if you take these functions, number 1, this one, x cube plus 3. So what are the domains for this x is, for this function is, every real value you can take it as a domain. First of all, you should know what is the domain of a function. Domain means the input values which are given to the function. கொடுக்குற the function எதோட x valuesக்கு நம்ம evaluate பண்ண முடியும் அன்றது தான் domain. புரியுதா? Domain means input. நீங்கள் சாப்பிட்ற மாதிரி input is the domain. So சில functions வந்து every x value it won't take. Some x values only it will take. Some x values it will reject. Okay, those x values, whatever the function takes, is known as the domain. So if we consider y is equal to x cube plus 3, similarly y is equal to x power 4 minus 2, if you put any value for x, whether it is a natural number, whole number, integer, whatever it may be, you can evaluate y value. So that's why every real number you can give it as a domain. So real number in the sense I can represent like interval notation also. Minus infinity to infinity. Minus infinity into infinity, open interval. Because I already told you cannot put closed interval for minus infinity, infinity. Because infinity there is no definition for it. It is infinite. So if somebody keeps closed interval, that is wrong. Okay, nobody will keep closed interval for infinity. For values only you should use a closed interval. So minus infinity, infinity means, what is the meaning means, in between whatever the values will get. For example, this is minus infinity to infinity. In between so many values are there, natural numbers, whole numbers, and then rational numbers, irrational numbers. Any x value, this function will take it as a input. Okay, this function also will take it as input. Okay, so that is the meaning of this one. So what about the third one? Can you guess what is the domain for third function? This function, okay, the y value for this function is evaluated for all the values of x except the denominator is 0. Because if the denominator becomes 0, something by 0, it becomes infinity. So what is the meaning of this one? For third function, you will give all real numbers present in the real line, but except minus 1. 10th standard also you studied this one. This is known as excluded values of the function. So whenever function is in the form of rational type p of x by q of x, then the denominator should be equal to 0. For those values, you cannot evaluate the function y value. Okay, so those values you have to remove. So x plus 1 0 means x is equal to minus 1. So minus 1 plus 1 0. So something by 0 infinity. So you cannot evaluate. That's why here the domain is r minus of minus 1. That means what? Except minus 1, it will take all real values. Similarly, this one, y is equal to square root of 4 minus x square. 4 minus x square means whenever function comes under the root, okay, under the root value should not be negative. It should be always greater than or equal to 0. That means what? Here 4 minus x square must be greater than or equal to 0. Because under root, negative value should not come. Negative means that is different, that is complex numbers. Okay, complex numbers next year you are going to study. So if you multiply with the negative sign, minus x square minus 1 less than or equal to 0, x plus 2 into x minus 2 less than or equal to 0. So x is equal to minus 2, x is equal to 2. So x value lies between minus 2 and 2, including 2 also. For example, I put 2 here, 4 minus 2 square 4, 4 minus 4 0, root 0 0, possibility is there. So minus 2 also possible, in between values also possible. That's why it is minus 2 less than or equal to x, less than or equal to 2. So if you want to represent like interval, you can represent like this also, closed interval minus 2 comma 2. That is also correct. Okay. So one important use of representing the functions analytically is you can find their domains as well as ranges. But here they explain about the domain only. Domain and ranges very easily. What kind of x values you can give it to a particular function to get the value of y. Okay, students. Now, what is another use of representing the functions analytically is you can draw their graphs very easily. Okay, for example, here f of x is equal to x by 2 plus 1. So, giving x values 1, 2, 3, 4, whatever it may be, negative values, you will get a straight line. So, like that for any function you can draw the graph by taking x values. Here also x square plus 4, it is a parabola. This parabola type, parabola, ellipse, hyperbola you are going to study in second year, that is a plus 2. Okay, but if you draw this graph, you will get like a parabola. Something like parabola means you study in 10th standard. Okay, it may come. Now another use, sorry, I will show you. So here another use of representing functions graphically is we can draw their graphs easily. How? Simply take some x values, corresponding y value you will get. Here I told f of x is equal to x by 2 plus 1. It represents a straight line. If you draw this function by taking some x values, definitely you will get a straight line. Because it is of the form y is equal to mx plus c. So it is a straight line. So f of x will x square plus 4. Generally, y is equal to x square is a parabola. Open upwards. Okay. So plus 4 also same thing, but vertex is shifted to some other point. You need not worry about that and all. First this represents a parabola, enough. At this stage it is enough. Okay. So by taking some x values you will get y values. So students, these are 3 ways of representing the functions. First is tabular representation of function. I am not telling much about that one because you already studied in 10th standard, tabular form. Okay, and then graphical representation you studied. but you should give much importance for analytical representation. So the major use of represent the functions analytically is you can find their domain and range, as well as you can draw their graphs, you can study the graphs, you can analyze the graphs. That is the major use of the analytical representation. So as you go to the higher studies, this representation only you are going to use much. Okay students. So what is the major form of analytical representation? Y is equal to f of x. Okay students. So if you like this video, please subscribe this channel. Okay, bye.